Welcome to the Forest Overstory podcast. This podcast explores forest stewardship in the Pacific Northwest, helping landowners and professionals gain new insights and information in the field of forest management. The Forest Overstory is a product of the Washington State University Extension Forestry Program and is supported by the Washington Department of Natural Resources and the Society of American Foresters. All right, welcome back to the Forest Overstory podcast. I am Patrick Schultz, an extension forester with Washington State University, here to host. For new listeners to the Forest Overstory, this is a podcast where we discuss forestry in the Pacific Northwest with experts, and in the process, hopefully informing and empowering small forest landowners, professionals, and well, really just anyone that's interested in forest stewardship. And I am joined by my colleague, Kevin Zobrist. Kevin, how you doing?
I'm doing well, Patrick. Glad to be here and recording another episode. We have a very special guest with us this morning. Karen Ripley from the U.S. Forest Service is with us, and we're going to be talking about a new issue this morning to the Pacific Northwest, and that is the emerald ash borer.
Yes, the dreaded emerald green beetle is finally here in the Pacific Northwest, and now it's something that we have to talk about. But I'm very, very glad that we have such a great guest in Karen Ripley to give us everything we need to know, right? How you doing, Karen?
I'm well, thank you.
That's great. Well, I think maybe we could learn a little bit more about what you do and what your position is before we really dig into anything. So you are a entomologist and forest health monitoring coordinator for the Forest Service. Can you tell us a little more about what that job is?
Yes. Well, the study of forest entomology historically has been the study of insects that kill trees or slow tree growth or damage wood products. And although forest entomologists know a lot more about other roles that insects have in the forest, that traditionally has been the bread and butter of our work. I also coordinate forest health monitoring for the West Coast, and that involves encouraging standardization of monitoring systems that are employed across all landowners and across the states from Alaska, Washington, Oregon, California, Hawaii, and the Pacific Islands as much as we can, so the data that are gathered can be knit together and represent kind of a higher purpose. And the third thing, well, another element of that forest health monitoring is to supervise the aerial detection survey program, where the trained observers fly every year and map where they see recently killed or defoliated trees. And I also coordinate a small grant program that supports investigations of the extent, the severity, or the cause of forest health problems.
Wow, so what do you do with all your free time? Just
Well,
sounds
I've
like a
spent
big
a
job.
lot of time lately looking at ash trees. It is zero fun to go for a walk with me in the city or near a riparian area because I'm easily distracted.
That's funny. Yeah, and I'm sure you're a source of doom and gloom for some of your non-naturalist friends. I know I happen to I do that quite a bit when I'm out on walks. Well, that's a great segue to our topic today, which is emerald ash borer. And in the state of Washington, this is not something that we have had to worry about. Certainly, some folks might have heard about this beetle from back east, and maybe are a little aware of its effects or potential damage. But I think by and large, this is maybe catching the layperson a little off guard, not really knowing what to think about the beetle. Maybe you can give us a little bit of background on, its history in the U.S. and what people can expect.
Sure. Well, the emerald ash borer, its Latin name is Agrylus planipennis, is native to China, Japan, Taiwan, and the Korean Peninsula. And it is historically, it has been a secondary pest, so it doesn't kill healthy trees, it kills trees that are weakened. Uh, by some other agent. And it was accidentally introduced to the United States to Michigan. It was detected in 2002. It had probably been there about 10 years when they started noticing uh, ash trees dying very rapidly, and they were infested with this new beetle. It's called the emerald ash borer because it's vivid, bright, metallic green with actually kind of a pinky black surface of its exoskeleton under its wings. It's very eye catching. And since it was detected in Michigan, it has killed hundreds of millions of trees in the United States. It has spread to the east and to the south. Until this year, it had occupied 35 states, 6 Canadian provinces, and Washington, D.C., and leaving in its wake uh, millions of dead trees. In most ash forests, it kills pretty much every ash tree bigger than about 3 inches diameter. And it made the jump to it it made the jump to Colorado a few years ago, and where it's infested mostly urban ash trees. And it made the jump. It was detected this last summer in Forest Grove, Oregon.
Karen, how does this insect kill trees? What do they do to the trees?
Like other, it's a flat-headed wood-boring beetle, the family Buprestidae, and like similar to bark beetles and other flat-headed wood-boring beetles, the adult lays eggs on the surface of the tree, and a larva hatches and bores beneath the bark, and they stay right at the surface where the wood and the bark meet, feeding on the phloem and kind of scoring the sapwood. And this disrupts the tree's vascular tissue. It's both its ability to move water, but more so its ability to move sugars from the leaves throughout the tree. And that is what kills them.
So how did this get here? How did it make the jump to Colorado and then out to Washington? How is this thing moving around?
Well, it probably came to Michigan initially associated with trade and shipping. There's a long history of using skunky, junky wood full of insects, full of rot or decay, both as pallets for many decades, or for weight and balance loading materials to dunnage that would help brace a load in a ship's hull. So it probably came with trade to Michigan. And then since then, it's spread. Part of it's been natural spread. The insects in on their own, the adults prefer to fly just a few hundred meters, less than a kilometer, less than a about a less than a half a mile on their own, especially if there's lots of ash around to continue infesting. They are able to fly long distances, up to probably 15 to 20 miles with, if they needed to. Those tests are done on little flight mills, similar to little treadmills, where they fly a beetle to exhaustion, which isn't really a natural situation, but they are capable of flying longer distances. And then, but the real wild card in the movement of invasive species are people, and probably through movement of firewood that people are gathering and gleaning from dead or dying trees. Perhaps there's been a role of the nursery and horticultural industry, which came under quarantine pretty quickly, and has a lot of controls. So I'd put my money on people moving firewood, which is a big disappointment. That's a behavior that we can control, but it's also really challenging, really ingrained in people to glean firewood from the dead and dying trees and move it even very long distances as they recreate or as they move. It's an unfortunate part of our culture, I think, to and one that we should work pretty hard to resist and change.
Karen, you mentioned that it had been around in Michigan for about 10 years before it was noticed. How long do you think it has been in Oregon where they found it this past summer? And do you think it has made its way to Washington yet?
So it was found in Oregon in a schoolyard, an elementary school that had about 10 or 12 years ago. They redid the front parking lot and they installed some surface water swales between the rows of parked cars and planted some ash trees as part of that landscaping in those wet swales. So those trees had been there uh, about 12 years. And from the signs of the emerald ash borer damage, several of them were dead. So most of them had some kind of canopy dieback. And as they were taken down and the bark was removed, you could see several layers of kind of overlapping uh, galleries, tunnels made by the beetles. So the thought is that they'd probably been there 3 or 4 or 5 years already before the decline in the trees themselves, just small saplings, was noticed. Um, when as we've been looking around the area of Forest Grove, which and the town of Forest Grove is about it's about 20 miles to the west of Portland. It's about 15 miles south of the Columbia River. Um, as we've been looking around Forest Grove, it strikes me that it this insect is so cryptic in the first few years of the infestation of a tree. It's high in the canopy where it might cause some branch dieback initially, but then as it moves down the trunk, you see other expression of a response, epicormic branching, water sprouts. But one of the last things that you see are these D-shaped exit holes. So about an eighth of an inch across, the shape of a capital D at eye level. And as I've spent many afternoons in Forest Grove looking at ash trees and even trees that I know because there are some bark splits that you can see the tunnels back and forth underneath the bark. It's the D-shaped exit holes, which are the real confirmation characteristic, are so late to show up that it's really hard to identify this insect in the early days. Another thing that's so Kevin, I don't think they've made it to Washington yet. The work that's been done to evaluate around the Forest Grove area shows that the infestation seems to be confined pretty much to about a 6 mile diameter area. But I also have a lot of respect for the concept that it's probably a couple of years past that 6 mile diameter area in terms of spreading, but we just can't detect it yet.
Yeah, that it is such a tricky pest for that reason. As you say, it starts top down in the tree, and not a lot of us are spending a lot of time up at the tops of trees looking for signs of insect damage. So it does. It makes it really tricky to get ahead of. And I want to talk a little more about spread and how it might look in Washington and Oregon compared to how it might look or how it did look back east, rather. So, I actually grew up in about a half hour from Garden City, Michigan, I believe, which is just outside of Detroit, where I think the first positive ID of emerald ash borer was found. And it was one of the things that actually got me interested in forestry. But watching it spread through southern Michigan so quickly is really remarkable, considering what you said, that at most these beetles are flying 15 miles in a year, or in their life. And if you think, oh, it's been here for about 20 years, 15 miles, Actually, they should only be spread 300 miles, but it's spread, as you said, through human movement. And you see these epicenters starting at like campsites and things like that. And that's really how it spread. And now it's, I think, in like 32 states, including Oregon or something along those.
Oregon's the 36th state.
36th state. Yeah. So really remarkable spread through human behavior. But you also have to take into account, the different forest types. Ash is it's a big and more widespread component of forests back east, and there's way more species of ash. The way that ash is sort of spread in Oregon and Washington, well, one, we only have the one native ash, that's Oregon ash, Fraxinus latifolia. We have a number of urban uh, or ornamental species that get used in urban landscapes, which we can talk about. But I'm just really curious, because Oregon ash is such a niche species, and maybe you could tell us a little bit about that, about how you see it spreading in Washington, because that dynamic is a little different, and it may spread along these riparian corridors rather than sort of more dispersed spread as they saw back east. And then we can maybe dig into the impacts of that.
Okay. Well, in the Forest Grove area, the majority of the trees that have been confirmed to have emerald ash borer are urban trees, street trees, and park trees that are easy to evaluate. But there are a significant number that are in natural riparian forests, as well as plantings that have been made adjacent to riparian forests of the native Oregon ash in order to support the restoration of riparian areas. Our native Oregon ash, Fraxinus latifolia, is typically found in wet areas. It has a very high tolerance for flooding, inundation in the winter, and then complete dryness in the summer. And what I'm told is that the emerald ash borer adult beetles prefer to fly kind of to the easiest adjacent ash tree. So down creek ways, and rather than going across the ridge that separates watershed, they'll tend to go downstream or upstream and spread that way. There is a not insignificant amount of couple of details about that, I guess, are that there's not a whole lot of topographic variability from one watershed to another in the Willamette Valley. There's, it's a huge, broad floodplain. And so from one creek to the next, it doesn't mean you have to go across a mountain range or a big high ridge. But, and I think there's also a lot of connection that's been made by people in the ash that they have planted. Ash is especially these European varieties, or excuse me, these North American varieties of ash, green ash, white ash, velvet ash, are really a workhorse of urban tree plantings and street tree plantings. They have high tolerance for all sorts of sort of urban abuse. And so they also provide a natural connectivity between the native ash growing in wetlands and watersheds. So I'd imagine this site in Forest Grove, there's overland connections through urban plantings. It's not that far from one stream to the next, and it's not that far downstream to the Tualatin River, downstream to the Willamette River, downstream to the Columbia River, and then across the border if they don't just go overland more quickly.
Karen, does this insect, does it only affect ash species? Are there any other species that it affects? And how about the mountain ashes?
It affects trees in the family Oleaceae, the olive family. That's where ashes are represented. So it does also affect olives, the olives that olive oil and the olive industry is based on. And there is a small niche olive oil industry in Western Oregon right now. So that's at risk. Another tree in that group that's fairly commonly used in horticulture are the white fringe trees. And but you mentioned the mountain ash, and although the common name is ash, mountain ash is not in that family and is not a host of the emerald ash borer.
Thanks, Kieran. Yeah, I've already received a lot of questions about, how are people's ornamental mountain ash trees going to be affected by this? And it is interesting. I didn't know that the fringe tree was in the Oleaceae family. So
Yes.
yeah, that's interesting. I wonder if we can talk a little about the potential impacts. We've discussed Oregon ash and just how niche of a species it is. You said it tolerates those really saturated, inundated soils, really, then become very dry in the summer. And what I've noticed is that a lot of those areas become dominated by ash because no other species can really handle it, especially in those really really wet areas. Even cottonwood doesn't like that stuff. So you get these areas in natural settings where Oregon ash is completely dominant, and it's a wetland, so it's a sensitive site. So I wonder if you can speak a little to what that means, maybe for riparian areas, and then also, what is it going to mean for urban areas? Because we can't leave those out either.
Well, I guess I'll start with the excuse me. I'll start with the riparian areas. That it This is a very dire situation for riparian areas, especially those portions of riparian areas that are currently dominated by Oregon ash. We've mentioned a couple of times this incredible capacity that it has for tolerating inundation and dryness. And there really isn't any other Pacific Northwest native species that has that same level of tolerance, as well as the ability to become a canopy tree and provide the shade, provide the erosion control, provide the seeds, the mast that make Oregon ash such a valued part of the riparian areas. Um, there are certainly some areas that you think, well, if the Oregon ash weren't there, would some of these other trees actually have capacity to move onto those sites a little more than they're growing now? And that's a high priority for research in the Pacific Northwest. There are several groups that are considering ways that they could underplant what are currently Oregon ash dominated forests and determine whether there are some sites, whether there are some swales or some wetlands that other species could tolerate if they didn't face the competition from Oregon ash. Um, Candidates for those studies include, you mentioned cottonwood, Pacific willow, Oregon white oak, and the West Side ponderosa pine are also candidates. But the fear is that there are sites that will no longer have a canopy tree that can tolerate those conditions when emerald ash borer um, removes all the big trees. We're like those sites are likely to see that every tree above about 3 inches diameter is killed, and although there will still be young trees, the seed crop will be um, lost or severely depleted, and so there are high consequences of this. In urban areas, cities vary in how much of their urban tree inventory is represented by ash. It is a very popular species. It was especially popular after Dutch elm disease started making its way across the country. And people thought, well, we've got to diversify. And a lot of those eggs went into the ash basket. And didn't result in as much diversification as with forethought, hindsight, we would have preferred. Um, some cities have 2 or 4%. I've heard the city of Eugene has about 8% of its urban tree inventory is ash. And when those trees start to die, probably in a very short time frame, maybe over 4 or 6 years, that represents a huge hazard because when ash dies, it tends to be very brittle and breaks easily. It's a challenge to remove dead trees, and replacing dead trees are always a high cost to an urban government.
Yeah, I think that's really interesting. I've read, and either of you can check me on this if I'm misspeaking, but from a sort of financial or economic loss perspective, emerald ash borer is the most devastating invasive insect in the US. And a big cause for that was, at least back east, uh, ash is just a really common urban species. In some cities, as much as 30% of the urban canopy. Um, and yeah, when you start to factor in the loss of value to your home, trees improve property value. You factor in the cost of removing a hazard tree, which anybody listening has had to do that knows just how expensive that can be. It gets really, really expensive. So those urban areas are certainly not going to be without their impact. And something to consider too is, especially low income communities that have a lot of ash and the difficulties associated with getting those removed and the costs. It can cause real hazards. So it's important not to leave the urban areas behind in this conversation. But I think it sounds like what you're saying from in natural settings in forested areas, for listeners that maybe aren't as aware of uh, the forest composition in Western Washington, Oregon ash is not the most common species by far. I mean, it is niche though, and where it exists, it's dominant. And so what we're going to see, I think, is really concentrated damage. And there will certainly be some landowners that don't have any Oregon ash, and the borer will sweep through, and it will have left them completely unaffected. But for some landowners, and not just private, public, too. I think of some wildlife refuges that are dominated by ash. This is going to be a really big deal, and it's a really big deal for that riparian ecology. And I'm really glad to hear that there are research efforts looking into replacement species. And those 4 that you listed sound like really good candidates. And maybe we can pivot here now and talk a little bit about, steps forward, how to deal with this. You mentioned underplanting as an option. Um, and the thing that I hear about most often when it comes to management of emerald ash borer is something called SLAM, which stands for slowing ash mortality, which is, I guess, the best tool we have in our kit. And it's not about preventing, it's slowing. And that says something about the efficiency of this pest. But I wonder if you can explain SLAM to us a little more.
Well, I'll start by saying, why are we talking about slowing ash mortality? Couldn't we be talking about eradicating the emerald ash borer? And I think the eradication's not an option. It's already been here long enough. It's already spread far enough, and it's so difficult to detect in the early stages that we wouldn't have a chance, even if we got out all the effort of the CCC or a moonshot or something. It's just the the barn door's been open long enough, and the cattle are gone. The Now the SLAM strategy, slow ash mortality, is based on kind of uh, two premises. One is to keep the population low and to discourage the population from spreading. And so keeping the population low is generally being done by detecting where there are infested trees and removing infested trees when you can, while the beetles are still in their larval stages or pupal stages inside the tree trunks, and processing that material either by chipping it or burying it or burning it or processing it into some other wood product that involves pretty much chopping up the bark and the outer 1 inch of the wood. Um, so that's how you'd de- reduce the population of insects that's already there. And then in terms of reducing the spread rates, would there's efforts being made to attract the beetles to specific trees and then kill those pioneering beetles through similarly um, processing and treating those trees. The way that you attract a beetle, the the agrylus beetles, this genus of metallic wood boring beetles, don't seem to have a long range pheromone that attracts them to anything or attracts them to each other. And so there isn't a very effective lure for the emerald ash borer. So we can't pull them into traps or otherwise concentrate them by some kind of natural or artificial lure. The best lure that's been discovered so far are the chemicals that trees themselves give off. There's a chemical that's released by injured ash trees or just the ash trees themselves. And that's a somewhat effective lure, but it doesn't compete very well with a real tree. So that's not so great. Um, the most effective way to attract emerald ash borers has been determined to be a girdled tree. And so in the perimeter of where the emerald ash borer has been found in Forest Grove, and as this perimeter expands forward, there are selections being made of 4 or 5 trees that once the leaves are have emerged and unfurled in the spring, this little group of trees will be girdled, and that hopefully will be an attraction that will draw the population that's spreading and dispersing from the currently infested areas into that little patch that's nearby, that's easy for the beetles to get to. And then in the fall, those trees will be cut and processed and debarked. In the early stages, there'll be a lot of research onto how many emerald ash borers did they attract. But I think over time, that strategy becomes more operational, and you're just cutting those trees down and processing them to kill any beetles they contain. Another element of slowing ash mortality is the use of pesticides. There's an injectable pesticide, several injectable pesticide, but the one that seems to be getting the most acclaim and having the most success is a product called emamectin benzoate. It can be injected into trees, and then also, if those trees are girdled, then those become lethal trap trees, and beetles that um, come and infest those trees will be killed. The emamectin benzoate works for about 3 years between injections, and so that tree can stay on the landscape and continue to attract and kill kill the beetles that are not inclined to disperse further. Hopefully, they'll just stay in the area and be killed in these nearby trees.
Karen, these injections, how are these done? Is this something, for instance, a homeowner could do themselves, or is this something that arborists do?
Um, the emamectin benzoate is generally a restricted use pesticide, so it requires a licensed applicator. It also requires some some equipment to do it. There are holes drilled and injectors inserted at the base of the tree about every 4 or 5 inches around the diameter at the base of the tree. And then the pesticide is injected into the sapwood and is carried up through the trees to the leaves. Part of the emerald ash borer's life cycle is that in the spring, when the adults emerge from their pupation chambers under the bark, they'll go and for 2 or 3 weeks feed on the foliage of adjacent ash trees. And so, if this pesticide's present, the beetles will be killed from just feeding on the foliage. And then, as the season progresses, beetles that lay their eggs and larvae that tunnel into those uh, treated trees will also be killed.
How about biocontrol? It sounds like there are a few promising species of parasitoids for biocontrol.
Yes, that is really a good story or a good facet of the work that's been done over the last few decades in response to emerald ash borer. There are 4 wasps that have been collected back in the native range of the emerald ash borer and brought to the United States and tested thoroughly and are now available for release to combat the emerald ash borer. There, one is an egg parasite that lays its egg on the eggs of emerald ash borer and kills that egg. There are 3 larval parasitoids that lay their eggs within the growing larvae, and then the larvae are eaten alive or killed and eaten by the progeny of these wasps. They're very tiny. You don't have to worry about, oh my gosh, is it another northern giant hornet or more yellow jackets? These are tiny wasps, smaller than mosquitoes, and only feed on the emerald ash borer, don't even feed on other agrylus beetle species that are native. But APHIS, the part of the United States Department of Agriculture that deals with invasive pests primarily, USDA APHIS, Animal Plant Health Inspection Service, has taken the lead on breeding these parasitoids and making them available for release across the country where emerald ash borer exists. And these parasitoids are very precious. They're difficult to rear. Imagine you have to have a you have to feed them on emerald ash borer larvae and grow them and have to figure out how to harvest them and transport them to new areas for release. And we're really fortunate on the West Coast that the country is very committed to um, releases in new states and new counties. And we've had 2 sites near Forest Grove approved for release of 3 of the 4 biocontrol parasitoids. One, it only really flourishes in the south, so it probably gets too cold here for it. But the other 3 will be released this spring, and that requires a threshold. You have to have a site that's at least 40 acres in size. It has to have infested ash trees, and it has to have ash trees of various sizes. So even if the the most mature, largest ash are killed, which is expected, that will happen, there will still be younger ash kind of growing into susceptible sizes that will sustain a low emerald ash borer population and sustain these parasitoids. There also has to be a commitment that that land won't be harvested for at least 10 years. So there were 2 sites identified in the Forest Grove area, and there's been tremendous support from folks in the eastern United States to to teach people out here the methods for releasing the parasitoids, and then 1 year later doing follow-ups to ensure that the parasitoids were able to become established.
Karen, I'm really glad Well, I'm glad that Kevin brought up biocontrols, and and your explanation made me think about the long game. Um, biocontrols are a really important part of the conversation of slowing ash mortality, but nobody is expecting them to sort of stem the spread. They're just not really a powerful enough tool to do that. But they are going to be a really critical piece of the long game, which is hopefully to come to a naturalized state with emerald ash borer. I really don't know anyone, even back east, that's sort of giving up on ash as this extinct species or doomed to be extinct species. Instead, I think the idea is that a combination of biocontrols and perhaps genetic resistance would lead us to this sort of naturalized state of emerald ash borer. Can you talk about that a little bit, and maybe if there's research efforts looking into that of what the long game could be?
Yeah, I think you're correct in that the initial game is preparing for significant mortality of mature trees, but the longer game will be that we're going to emerge from this initial emerald ash borer wave with young ash trees that are still out there. Hopefully, we'll still have some ash trees that are seed bearing size to sustain that young population. And and then hopefully there will be some trees, whatever size they are, that have resistance to the emerald ash borer. And there is variation in resistance in some of the species that are present on the East Coast or in the Midwest. Some trees that are more resistant than others. And overall, Oregon ash appears to be among the more susceptible trees. There may be pockets of resistance, there may be diversity that can be selectively bred for. Initially, there have been, I think there are 20 or 25 or 27 different families of ash seed that has been collected by the Dorena Genetic Resources Center in Cottage Grove, Oregon. And those trees were have been grown into seedlings, and they're going to be exposed to the emerald ash borer in the Midwest, and to see if there's resistance that can be discerned among those families, couple of dozen families. There's also been an effort in the last 3 years to collect 1 million ash seeds, and these seeds are being banked just for preservation, and some of them are also being um, kept with the hope that they would be available for additional tests of resistance.
So, Karen, what should people be doing right now, both on the homeowners and landowners side of things, and then on the agencies and municipalities side of things, in terms of both vigilance, watching for this, and how do people report a suspected sighting, and then also preventative measures? If people along the southern border of the state start now with injecting trees, what do you recommend?
Well, a couple of the easy specifics for your question, Kevin: vigilance uh, and reporting. Um, there's a hub website that is just getting its feet under itself of www.oregoneab.com, that's being developed as a hub with information about emerald ash borer and the work to respond to it in in Oregon and Washington. So that's a place that people can keep their eye on and just be alert to the Washington State University Extension, Oregon State University Extension are putting out a lot of information as we aggregate what's known about um, ash and the decisions that people will face regarding ash. If you suspect that you have emerald ash borer, First of all, it's important. It needs to be an ash tree or an olive or a white fringe tree. And most people are recommended to report that through the Washington Invasive Species Council's hotline. There is a prominent on the website of the Washington Invasive Species Council is a way to report an invader, and those reports are paid attention to and watched. You can put in the location, you can put in photographs of what you're seeing, and someone will follow up on that to determine whether in fact that is emerald ash borer, or whether it's some kind of look-alike, or not something that needs to be uh, of concern at this time. So anybody can do that. The As far as a more general response that communities and landowners need to take, I think they need to be um, evaluating their ash. How much ash is on your property, and what are the benefits that it's giving your property at this time? And is that worthy of protection? Some of these trees, and I think there's been research that faced with the cost of removal and replacement and losing ecosystem services, it, even though it can cost $100 to $300 a tree to do these pesticide treatments, that they're worth it, and just to protect that tree through the initial wave of mortality. If you don't feel that you want to protect any trees with the pesticides, just getting ready for anticipating that within the it's very difficult to determine how quickly, how fast the emerald ash borer will be able to spread and when it will reach your property. But being ready that there will be, um, most of these mature canopy sized trees will die. Other things people can be doing is participating in seed collection efforts. They're still ongoing, even though the million seed mark goal was met in the last 3 years. There's still opportunity to collect more seed. There, some private landowners may have the opportunity to participate in research, and some of these studies about um, what trees might be good substitutes, what, and just monitoring what are the effects, so we can survey what the before and after looked like and understand more the impacts of emerald ash borer. I think um, it's worth, as you evaluate your property, especially the sites that have ash, considering what's going on with the invasive species underneath the ash, because if that shade causing ash disappears, those that reed canary grass or those blackberries or that Scotch broom that's now daylighted is just going to be ready to go like gangbusters. And then I think the last and probably the most universally relevant suggestion is um, to get on the bandwagon for not moving firewood, especially any kind of firewood that includes ash at this time. We've really that's what's going to blow these slow ash mortality efforts out of the water, is when somebody takes a pickup load of wood from an infested ash tree and drives it 30 miles or 80 miles and starts a new infestation spot.
That's a really good point, Karen. We need to focus a lot of efforts on education towards prevention, because the sort of spread, that long range spread, sounds like is fully preventable.
Yes.
What do you see coming in the future in terms of the science and the research on emerald ash borer? Are there new chemical or biological control options that are on the horizon, or maybe new and better detection technology, or maybe even genetically resistant tree breeding? What do you see coming?
Well, the probably the holy grail, what would really be helpful is in terms of the insect would be finding a lure, finding some kind of communication chemical that we can use to interrupt the beetle's ability to communicate with each other and their ability to effectively find a host plant. Uh, in terms of the tree, if we can determine there's genetic resistance and start breeding to increase that throughout the populations of Oregon ash, that would be really important. Um, Other things, silviculturally, how to manage ash or how to manage the the characteristics of a wetland forest to ensure that those characteristics like shade and cool water and suppression of invasive species are perpetuated is uh, probably the highest priority that I'd see from that front.
All right. Well, we need to start wrapping up. I'm sure we could absolutely keep going for probably another hour. Karen, it's been amazing to have you on. You've given us so much good information, and I definitely want to reiterate and underline that one of your last messages, which is to don't move firewood. I think we have a pretty diverse audience between forest owners and professionals and the public, but that's something everyone can do. Uh, they say buy it where you burn it. It's a great way to ensure you're not spreading any forest health pest, even aside from emerald ash borer. And it's also a great way to support your local forest owners roadside firewood stand. So all good things to buy it where you burn it. But um, for those listening, I'm sure that, as Karen said, there's going to be a lot more information coming out of WSU Extension, OSU Extension, Washington Invasive Species Council, as this thing kind of rolls out. So it's really important to stay tuned to that. But Karen, I want to thank you again for joining us. Kevin, did you have any other thoughts? Any final messages?
I just want to thank Karen for being with us today, and Patrick, thank you, and thank all of our listeners out there. We're so glad to have you with us, and we do hope you'll join us next time. Don't forget that all of the episodes for the Forest Overstory podcast are available to you on the WSU Extension Forestry YouTube channel, and we look forward to seeing you next time on the Forest Overstory podcast.